Hello, welcome to the New College Durham Engineering Workshop. In this series of videos I'm going to be introducing you to the principles of the centre lathe, the history of the centre lathe and the safety aspects of the centre lathe. This is a typical centre lathe. It's a Colchester Student 1600 and it's industry standard machinery. The basic principle of the centre lathe is that if you take a piece of material such as a plain piece of steel bar, clamp it into a chuck. While that chuck is rotating, the workpiece is rotating, and then a cutting tool appropriately will be introduced onto the workpiece as it is spinning, and the tool can be then used to shape the workpiece as necessary. Using various tools and processes, the plain piece of bar can be changed to any form desired. So a plain piece of bar, a finished component, a finished workpiece. Now, the lathe's been around for several thousand years in one form or another. The ancient Egyptians and the ancient Romans used lathes, very basic lathes which were usually foot powered, and they used those to turn items of wood. Okay. So the lathe has been developing through the ages and very close to the modern lathe during the Industrial Revolution, where steam power was used to drive belts in factories, which was then used to power lathes. Obviously we have now modern lathes which are used in industry today. As with any workshop process, one of the main considerations, in fact the main consideration, is safety, to make sure no injuries are sustained while using the machine. The main hazards involved in the use of the lathe is firstly entanglement. Entanglement means part of yourself or part of your body becoming entangled in the rotating machinery, specifically the rotating chuck. The chuck rotates when the power is switched on. It's obvious that while that chuck is spinning, no part of your body or clothing or any other part of your person should be in contact with the chuck. It's obvious that no part of your person, hands or any other part of you should be in contact with the rotating part of the machine while it's in motion. Other hazards are cuts, potentially from sharp edges of the workpiece, from sharp edges of the tool, and also from swarf. Swarf is the waste material which is removed from the workpiece during the cutting process, and this swarf, if handled incorrectly or if handled carelessly, can be very sharp. The swarf can also be very hot due to the heat produced with the friction of the cutting action. The swarf, when it comes off the machine, can also be very hot. Safety precautions, firstly, must be eye protection. Eye protection must be worn at all times. Safety glasses or a suitable face shield must be worn at all times. If you have long hair, that must be tied back or secured inside a cap. All jewellery, rings, bracelets, watches, anything of that nature must be removed before working on the lathe. And this is another precaution against possible entanglement. You should never wear gloves when you're working on a lathe, because potentially the glove itself could be caught in the rotating machinery and pull your hand into the machinery. It's possible that you may get a nip from when you're using spanners or any other types of tool to adjust the machine. So you need to make sure that you don't get nips from tools. When you're changing the chucks are obviously quite heavy. You may need to make sure that you don't get your hands caught underneath the chuck and squash your fingers. In this video I'm going to be explaining the main parts of the lathe, what their function are, and some safety aspects. The main part of the lathe is the headstock. Inside the headstock are two gearboxes. The first gearbox is so that you can select different RPM speeds. They're selected by using these handles here to select an individual RPM speed. If I want to select a high RPM speed, I can do so by moving the selection levers. The machine can't be switched on unless this chuck guard is in place. As you'll see, if I raise the chuck guard, the machine won't switch on. If I want to select a low RPM, I adjust the control, then I can have a low RPM. The selection of RPM depends on the work you're carrying out, the type of tool that you're using. Also in the headstock we have the controls for adjusting the tool feed rate. I'll explain a little bit more about those in further videos. Moving on, we have the spindle which runs through the headstock, and on the end of the spindle is attached the chuck or another work holding device. This central part of the machine is called the carriage. The carriage can be moved from left to right using the carriage hand wheel, and the carriage runs backwards and forwards on these runners, which is called the lathe bed. This part of the lathe is called the tailstock. The tailstock can be slid from left to right along the lathe bed, and it can be locked in position using the locking lever. The tailstock spindle can be moved forward and back using the tailstock handle, and if a chuck is fitted into here, it can be used for drilling holes in the workpiece. Inside this part of the machine there is a shaft which runs and drives the feed. This screw shaft is used for cutting screw threads, which I'll explain in a later video. The tool can be moved forward and back by using the cross slide hand wheel. Turn it anti-clockwise, the tool moves away from the workpiece. Clockwise, it moves towards the workpiece. This part is called the compound slide, or sometimes called the top slide. That can move the tool from left to right by using the compound slide hand wheel. This is used for cutting tapers, which it will be explained in a further video. We have a digital readout which can be used to help find the position of the tool. As you can see, it measures in millimeters and changes according to the movement of the tool. To start and stop the machine for normal operation, the start-stop lever is located on the right-hand side of the carriage. It needs to be pushed slightly to the right as it has a spring and downwards. To stop the chuck, gently lift the lever up till it springs into the neutral position and wait for the chuck to come to a halt. You should never change gear while the chucks rotate. The chuck guard has an electronic switch, which means that when the chuck guard is raised, the machine will not switch on. You must always check that this switch is operating correctly, because if the machine can switch on when the chuck guard is up, this is a safety hazard. We have safety mechanisms on the lathe which can be used in an emergency situation. If, say for example, your workpiece is coming loose from the chuck, or your tool breaks, the emergency stop button. Press that in, the chuck comes to a halt. The machine won't start again unless you release the emergency stop by turning it slightly anti-clockwise until it pops out. The machine also has an emergency foot brake. If you press firmly on the foot brake, it cuts the power to the chuck, and it also puts a brake on which stops the chuck instantaneously.